Yes. Good afternoon. Welcome back to second PU electronics classes. Today I am going to take the topic of D flip-flop. So in my last class we studied about clocked SR flip-flop. Clocked SR flip-flop. Flip-flop itself indicates that the device consists of clock signal. Otherwise, it would have a latch. Okay. Now, so we have seen in the truth table of clocked SR flip-flop, the last condition when clock equal to 1. If I made S equal to 1 and R equal to 1, then Qn and Qn bar both switches to logic high state, which is undesirable condition. Okay. By mistake, if I apply both S equal to R equal to 1, flip-flop undergoes forbidden condition, invalid state. That should not happen in any flip-flop operation or in memory operation, because Q and Qn bar are complementary outputs, okay, which are not observed in this particular case. And what is the remedy for that? And whether the clocked SR flip-flop itself can be used as a data storage device, whether we want we can change some internal structures to store binary number, either 0 or 1. Is it possible? So some questions are arising here, and the remedy is D flip-flop. Okay, basically a D flip-flop is a data flip-flop, D for data, which can be used to store binary number. Okay, binary digits 0 and 1. See, if I write the truth table of clocked SR flip-flop, clock SR Qn bar, clock 0 Sx Rx, whatever may be the value of S and X, S and R, Qn remains in previous value, Qn minus 1 bar. If clock equal to 1, S0 R0, once again Qn minus 1 bar. If clock equal to 1, 0 1, Qn 0, Qn bar 1, this is reset. If clock equal to 1, S1 R0, this is set, and last one 1 1. So here we can see same logical levels at the outputs of Qn and Qn bar. Now see, we want only 3 conditions in any flip-flop operation, in memory operations. So one is hold. Where is hold? That can be observed in this is hold, reset, set, last one invalid. Okay, so here we have 5 states. So out of 5 states, desirable is reset and set. It is mainly a required state, and invalid states are undesirable. Okay, and if clock equal to 1, see, if clock equal to 0, automatically we will get a hold condition. So we need not apply S0 and R0. See, this is undesirable. So only 3 conditions are required in flip-flop operation. One is set. What is the use of set? We can store bit 1. Okay, if Qn equal to 1, the bit 1 is stored by the flip-flop. At reset, the bit 0 is stored by the flip flop, and hold condition is to hold the binary number. Okay, no operation. Next, for this, look at the S and R conditions. Anyhow, clock equal to 1, clock signal is used to enable the circuit. And what about S and R? S and R, see, simultaneously both are not having same logical levels. See here, when S equal to 0, R should be equal to 1, and when S equal to 1 and R equal to 0. So while applying the inputs, input should be at the complementary states. Okay, and even in hold condition also, input should be in complementary states. It may not be in same states. Okay, so this condition can be used to construct a new device where we have only one input, that is D flip flop. See here, if I draw this circuit of clocked SR flip flop, I will write here. See, S and R may not be at same states. See, if S equal to 0, then R should be equal to 1. How R can be make? How it could be 1? How it could be 1? If I connect an inverter in between S and R, while applying the logic level at S, the same signal is applied at R. Okay, which is now inverted. The signal simultaneously applied, but it is inverted input of S. So R is nothing but S bar. Okay, see, an inverter is inserted. Inverter is inserted. So this is the new flip flop, what we call it as D. So instead of S, we mentioned it a new input terminal. We mentioned it as D. Actually, inside the flip flop, inside the chip, we have the clocked RS flip flop only. Clocked RS flip flop only. Now, its block diagram is like this. So while writing the block diagram of clocked SR flip flop, we have 3 inputs here, including clock. So this is the block diagram. Next, a working condition. See, when the clock equal to 0, when clock equal to 0, see, if clock equal to 0, you need not check the D input line. You need not check S and R, similar to clocked SR flip flop. Okay. If D equal to X, X can have either 0 or 1. So if D equal to 0 and D equal to 1, whatever it may be, irrespective of the level set S and R, so you need not discuss about S and R here. Need not discuss. See, only D input is considered. If D is X, X means either 0 or 1. If one of the input is at logic low level, both NAND gate will give logic high. Okay. If two logic high levels at the NAND latch it will lead previous value. D equal to x, the outputs Qn equal to Qn minus 1, Qn bar equal to Qn minus 1 bar, Qn minus 1 bar, that is hold condition. This is hold condition in the flip-flop operation. Okay, flip-flop is hold state. Okay, next, so when clock equal to 0, we need not apply the inputs. So we cannot change the output of D flip flop. Now when the clock equal to 1, if clock equal to 1, say we cannot predict the output unless we don't have the other inputs. So to get other input, we should apply D. So when clock equal to 1, apply case 1. If D equal to 1, or if D equal to 0, what do you have to do? If D equal to 0, this 0 is directly applied here, and a complementary state is applied here. This is 0, and because of this inverter here, you get 1. If D equal to 0, the first NAND gate will give logic high, whereas the other NAND gate, because of two high levels at the input level of a NAND gate, it gives logic 0. So if this input is 1, or this input is 0, Qn bar is 1, and this 1 gives logic low level. So Qn equal to 0 and Qn bar equal to 1, this condition is reset. This is reset condition. This is reset condition. See next, case 2. Case 2, under clock equal to 1 only, when D equal to 1, and this 1 is applied here, that is 0, because of inversion 0, and because of this 0 you will get logic high level here, and you will get logic low level here. If this input is low, this NAND gate will logic high, Qn equal to 1 and Qn bar equal to 0. This is set condition. This is set condition. Okay, and we don't have any alternatives here. ಇಲ್ಲಿ ಯಾವುದೇ ಆಲ್ಟರ್ನೇಟಿವ್ ಸಿಗುವುದಿಲ್ಲ ನಿಮಗೆ, ಯಾಕಂದರೆ ಡಿ ಆಲ್ರೆಡಿ 2 ಸ್ಟೇಟ್ ಬಂದಾಯ್ತಲ್ಲ. ಡಿ ಒಂದೇ ಇನ್ಪುಟ್ ನೀವು ಯೋಚನೆ ಮಾಡಲಿಕ್ಕಿರೋದು. ಎಸ್ ಮತ್ತು ಆರ್ ಅನ್ನು ಮಿಡ್ಲಲ್ಲಿ ಒಂದು ಇನ್ವರ್ಟರ್ ಕನೆಕ್ಟ್ ಮಾಡಿ ಸಿಂಗಲ್ ಇನ್ಪುಟ್ ಆಗಿ ಕೊಟ್ಟಿದ್ದೇವೆ, ಹಾಗಾಗಿ ಅದು ಡಿ ಇನ್ಪುಟ್. ಓಕೆ, ಸೊ ಅದು ರೀಸೆಟ್ ಕಂಡೀಷನ್. ನೆಕ್ಸ್ಟ್ ಫೈನಲಿ ಟ್ರೂತ್ ಟೇಬಲ್, ಐ ರಾಟ್ ಇಟ್ ಹಿಯರ್. ಟ್ರೂತ್ ಟೇಬಲ್, ಕ್ಲಾಕ್ ಡಿ ಒಂದು ಇನ್ಪುಟ್ ಮಾತ್ರ, Qn ಬಾರ್ ಸ್ಟೇಟ್. ಕ್ಲಾಕ್ 0 dx Qn equal to Qn minus 1 Qn minus bar. This is hold condition. Clock equal to 1, D equal to 0, this is 0 and this is 1, reset. Clock equal to 1, this is 1, this is 0, and this is 1, this is 0, this is set. Okay, So if clock equal to 1, D equal to 1, Qn equal to 1 and Qn bar equal to 0, this is set condition. And we don't have any undesirable condition here. Okay, nowhere it will happen. ಎಲ್ಲಿ ಕೂಡ ಇನ್ವ್ಯಾಲಿಡ್ ಕಂಡೀಷನ್ ಹೇಳು ನಿಮಗೆ ಇಲ್ಲಿ ಅಪಿಯರ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇಲ್ಲ, ಯಾಕೆಂದರೆ ಡಿ ನೀವು ಅಪ್ಲೈ ಮಾಡಲಿಕ್ಕೆ ಎರಡೇ ಕಂಡೀಷನ್ಸ್ ಇರುವಂಥದ್ದು. ಸೊ ಸರ್ಕ್ಯೂಟ್ ಈಸ್ nil of invalid state. Okay, next timing diagram. Clock. ನೋಡಿ, ಇಲ್ಲಿ ಡಿ ಅನ್ನು ನೀವು ಡ್ರಾ ಮಾಡಬೇಕಾದ್ರೆ ಯಾವುದೇ ಫಾರ್ಮ್ಯಾಟನ್ನು ನೀವು ಡ್ರಾ ಮಾಡ್ಬೋದು, ಇಲ್ಲಿ ಏನು ಸಮಸ್ಯೆ ಆಗೋದಿಲ್ಲ. ಹೇಗೆ ಡ್ರಾ ಮಾಡ್ತೀರಿ ಅಂತ ಕೇಳಿ, ಡಿ ಓಕೆ 0 0 1 1 ಸರಿ ಡ್ರಾ ಮಾಡಿದ್ವಿ. ಯಾವುದೇ ಫಾರ್ಮ್ಯಾಟ್ ಡ್ರಾ ಮಾಡಿ, ಅದೇ ಫಾರ್ಮ್ಯಾಟ್ ನಿಮಗೆ ಕ್ಯೂ ಎನ್ ಅನ್ನು ಕೊಡ್ತದೆ. ಕ್ಯೂ ಎನ್ನಲ್ಲಿ ಏನು ಬರ್ತದೆ ಅಂತ ನೋಡಿದರೆ, ಕ್ಯೂ ಎನ್ ಡಿ ಲೈನ್ ಹೇಗಿದೆ ಅದೇ ಕ್ಯೂ. ಸಿ ಹಿಯರ್ ಕ್ಯೂ ಫಾಲೋಸ್ ದಿ ಡಿ ಇನ್ಪುಟ್, ಕ್ಯೂ ಫಾಲೋಸ್ ದಿ ಡಿ ಇನ್ಪುಟ್. ಸೊ ನೋ ನೀಡ್ ಆಫ್ ವರಿ. 0 1 0 yes, like this. Qn bar just draw the complementary state of this image. 1 0 1 and this is the end of D flip-flop. See, very very simple working of D flip-flop. Okay, and an inverter is connected in between S and R flip-flop, and an extra input is, and the S input is extended to give D input, and basic NAND latch is used. That is the circuit, the brief circuit description of D flip-flop. Next, working condition: when the clock equal to 0, whatever may be the value of D, output remains in its previous value. And when the clock equal to 1, case 1, if D equal to 0, Qn equal to 0 and Qn bar equal to 1, that is reset. This is reset condition. See, when the clock equal to 1 and D equal to 1, Qn equal to 1 and Qn bar equal to 0, this is set condition. This is set condition. So finally, if I conclude the analysis, that becomes the truth table. See here, clock equal to 0, D equal to x, Qn equal to minus 1, Qn bar equal to Qn minus 1 bar, hold state. If clock equal to 1, D equal to 0 and Qn equal to 0 and Qn bar equal to 1, reset. If clock equal to 1, D equal to 1 and Qn 1, Qn bar 0, set condition. Okay, and next one is timing diagram. This is timing diagram. Okay, next see, up to here ಇಲ್ಲಿವರೆಗೆ ನಿಮಗೆ ಬಂದಂಥ ಎಲ್ಲ ಸರ್ಕ್ಯೂಟ್ಗಳು ಕೂಡ ಬೈನರಿ ನಂಬರನ್ನು ಸ್ಟೋರ್ ಮಾಡಲಿಕ್ಕೆ ಮಾತ್ರ ಯೂಸ್ ಆಗಿರೋಂಥದ್ದು. ಓಕೆ, ಬೈನರಿ ನಂಬರನ್ನು ಸ್ಟೋರ್ ಮಾಡಲಿಕ್ಕೆ ಮಾತ್ರ ಯೂಸ್ ಆಗಿರುವಂಥದ್ದು. ಓಕೆ, ಬಟ್ ಸೀಕ್ವೆನ್ಷಿಯಲ್ ಲಾಜಿಕ್ ಸರ್ಕ್ಯೂಟ್ ನನ್ನ ಎಕ್ಸಾಂಪಲ್ ಬೆಸ್ಟ್ ಇದು ಕೌಂಟರ್ ಸರ್ಕ್ಯೂಟ್ ಅಂತೇಳಿ ಬರ್ತದೆ. ಈ ಕೌಂಟರ್ ಸರ್ಕ್ಯೂಟನ್ನು ಹೇಗೆ ಡೆವಲಪ್ ಮಾಡ್ಬೋದು, ಅದಕ್ಕೆ ಅದರಲ್ಲಿ ಹಿಂದೆ ಇರುವಂಥ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ ಯಾವುದು ಅಂತ ಕೇಳಿದರೆ, ಮೇಯ್ನ್ ಅದರಲ್ಲಿ ನಿಮಗೆ ಕಾಣುವಂಥದ್ದು JK flip-flop. Okay, JK flip-flop is the basic circuit involved in counter circuit, JK. Okay, what is a counter? Counter ಏನು ಹಾಗಿದ್ರೆ, counter is a device which is used to count the number of clock pulses. Clock pulses ಎಷ್ಟು ಬಂದಿದೆ ಅಂತ ಹೇಳೋದನ್ನು ಕೌಂಟ್ ಮಾಡಲಿಕ್ಕೆ ಇರುವಂಥ ಒಂದು ಡಿವೈಸ್ ಕೌಂಟರ್. ಸೊ ಕೌಂಟರ್ ವರ್ಕ್ ಆಗಬೇಕು ಅಂತಾದರೆ ನಮಗೆ ಕೌಂಟಿಂಗ್ ಸೀಕ್ವೆನ್ಸಸ್ಸನ್ನು ಜನರೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಬರಬೇಕು. ಸೊ ಅಲ್ಲಿ ನಿಮಗೆ JK flip-flops ಹೆಲ್ಪಿಗೆ ಬರ್ತದೆ. ಓಕೆ, ವಾಟ್ ಈಸ್ JK flip-flop? JK ಅಂತ ಯಾಕೆ ಕೊಟ್ರಪ್ಪ? ಅಲ್ಲಿ ನಿಮಗೆ SR ಸೆಟ್ ರಿಸೆಟ್ flip-flop ಅಂತ ಬಂದಿದೆ. JK ಅಂದರೆ ಏನಪ್ಪ ಅಂತ ಕೇಳಿದರೆ, JK is the name of a person, that is Jack Kilby. He is Jack Kilby. J from Jack, K from JK flip-flop. Okay, so Jack Kilby ಹೆಸರನ್ನು ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದನ್ನೇ ಒಂದು J ಇನ್ನೊಂದು K, ರೈಟ್. ಹಾಗಿದ್ರೆ JK ಮತ್ತು Kಗೆ ಸೆಟ್ ಮತ್ತು ರೀಸೆಟ್ ಮಾಡುವುದು ಇನ್ನೇನು ವರ್ಕ್ ಮಾಡ್ತದೆ ಅಂತ ಕೇಳಿದ್ರೆ ಇಲ್ಲ. Instead of S, we have used the J. The function is similar to S, and the function for K is similar to R. So instead of R, we are using K notation, and instead of S, we are using J notation. This is the difference, not else. Okay. Next, Jack Kilby flip-flop. What is this block diagram? Block diagram is like this. See, JK and clock, QN and QN bar. This is block diagram of JK flip-flop. Block diagram of JK flip-flop. Okay. And how do you draw the circuit of JK flip-flop? See, basically JK flip-flop consists of clocked SR flip-flop, and inputs are gated. Inputs are gated. Next, gated using 2 AND gates. Okay, ಇಲ್ಲಿ ಸಿಗುವಂಥದ್ದು ನಿಮಗೆ S ಮತ್ತು ಆಮೇಲೆ ಇದನ್ನು ಪುನಃ ಗೇಟ್ ಮಾಡಿದ್ದಾರೆ. ಆ್ಯಕ್ಚುಲಿ SR flip-flopಲ್ಲಿ ಪುನಃ ಎರಡು ಸೆಕ್ಷನ್ಸ್ ಬರ್ತದೆ ಅಲ್ಲಿ. ಒಂದು ಫಸ್ಟ್ ಇನಿಷಿಯಲ್ ಸ್ಟಾರ್ಟಿಂಗ್ NAND ಗೇಟ್, ಇನ್ನೊಂದು NAND ಗೇಟ್ ಲ್ಯಾಚ್. ಅದೆರಡು ಸೇರಿ ಒಂದು SR flip-flop. ನಾನು ಇಲ್ಲಿ ಆ ಸರ್ಕ್ಯೂಟ್ ಡ್ರಾ ಮಾಡಲಿಲ್ಲ, ಜಸ್ಟ್ ಈ ಬ್ಲಾಕ್ ಡಯಾಗ್ರಾಮಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೇನೆ ಅಷ್ಟೇ. ಬಟ್ ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಪುನಃ ಗೇಟ್ ಹೇಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದರೆ, one input is used, one of its inputs are used to apply clock signal, and another input is used to apply 2 inputs, what we call it as J and K. And there exists another input which is the feedback. The one is taken from the QN bar. So this is the first gate, first AND gate. The one of its input is coming from QN bar, and one of the other input is coming from QN. So these are the gated inputs. So S is here. What is S? S is AND of clock and J and QN bar. QN bar. And R equal to here. What is R? R is the output of second AND gate. It is AND of clock, K and Qn and Qn. So if S equal to when S will be equal to 1, S 1 ಆಗೋದು ಯಾವಾಗ ಅಂತ ಕೇಳಿದರೆ S equal to 1 only when clock J and Qn bar equal to 1. S 1 ಆಗೋದು ಯಾವಾಗ ಕೇಳಿದರೆ ಕ್ಲಾಕ್ 1 ಇರಬೇಕು. ಕ್ಲಾಕ್ 1 ಯಾಕೆ ಕ್ಲಾಕ್ ಹೈ ಹಾಕಿರಬೇಕು ಅಂತ ಕೇಳಿದರೆ ಕ್ಲಾಕ್ ಹೈ ಇದು ಎನೇಬಲಿಂಗ್ ಸ್ಟೇಟ್. ಸೊ ಕ್ಲಾಕ್ ಹೈ ಇರಬೇಕು, ಆ್ಯಕ್ಟಿವ್ ಕಂಡೀಷನ್ ಇರಬೇಕು. ಆ್ಯಂಡ್ J equal to 1 ಇರಬೇಕು. J 1 ಮಾಡಬೇಕು ನೀವು. Qn bar 1 ಇರಬೇಕು. ಅಂದರೆ Qn bar 1 ಬರೋದು ಯಾವಾಗ ಅಂತ ಕೇಳಿದರೆ ರೀಸೆಟ್ ಕಂಡೀಷನ್ ಇದ್ದರೆ ಮಾತ್ರ. Qn bar 1 ಬರೋದು ಯಾವಾಗ ಅಂತ ರೀಸೆಟ್ ಕಂಡೀಷನ್ ಇದ್ದರೆ ಮಾತ್ರ. ಒಂದು ವೇಳೆ ಸೆಟ್ಟಲ್ಲಿದ್ದರೆ ಸೆಟ್ ಕಂಡೀಷನ್ ಇರ್ತದೆ, ಆವಾಗ S 0ನೇ ಆಗ್ತದೆ. ಓಕೆ. R equal to 1 ಆಗೋದು ಯಾವಾಗ? R equal to 1 only when clock equal to 1, K equal to 1 and Qn equal to 1. Qn equal to 1 ಬರೋ ಸೆಟ್ ಆಗ್ಬೋದು. ಆಮೇಲೆ K ಇನ್ಬಿಟ್ಟು 1 ಮಾಡಬೇಕು. ರೀಸೆಟ್ ಆಗಬೇಕು ಅಂತಿದ್ರೆ R equal to 1 ಕೊಡಬೇಕು. ಯಾವಾಗ ಅಂತ ಹೇಳಿದರೆ ರೀಸೆಟ್ ಕಂಡೀಷನ್ ಬರಬೇಕಿದ್ರೆ ಆವಾಗ K equal to 1 ಬರಬೇಕು. ಓಕೆ. K equal to 1 ಬಂದರೆ ಅವಾಗ ಅದು ರೀಸೆಟ್ ಕಂಡೀಷನಿಗೆ ಬರ್ತದೆ. ಓಕೆ. J equal to 1 ಮಾಡಿದರೆ ಸೆಟ್ ಕಂಡೀಷನಿಗೆ ಹೋಗ್ತದೆ. ಓಕೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಬ್ರೀಫ್ ಡಿಸ್ಕಷನ್ ಬಿಹೈಂಡ್ ದಿ ಸರ್ಕ್ಯೂಟ್ ಡಯಾಗ್ರಾಮ್. ನೆಕ್ಸ್ಟ್ ವರ್ಕಿಂಗ್. Now I want to discuss this in next class. Okay, thank you very much.